Hello and welcome to the final presentation of the EMRA Application project developed by Team Eastbound for CS6440 Health Informatics. My name is John Mansfield and I will be narrating on behalf of my team members Oscar Ornelas, Anthony Passamonte, and Phil Jones. First, let's take a look at our Gantt chart. All set due dates and milestones have been tracked and project requirements have been kept in scope. In this Gantt chart, you can see the project deliverables combined with the SDLC process we have followed. Let's look at the same data in table view. We can see the same data from the previous slide represented in table view. In-project milestones are highlighted in yellow and out-of-project milestones in orange. Also shown is our percent completed each phase for deliverable. Now let's take a look at an overview of our application. Our EMRA application can be seen as a proof of concept that demonstrates a medical alert system that interfaces with a FHIR server. This could potentially be any alert that is relevant to the provider, including the 4 demoed, and could also build to scale different levels of alerts. Alternatively, for smaller providers without the capability of running their own FHIR resource, this could also be run as a cloud solution with patient data uploaded to a HIPAA-compliant Azure cloud service. We believe our application is relevant today with provider fatigue, exposure to litigation, and lapses in physician or provider attention having an effect on both medical providers and patients. A few specific problems that we believe our application could assist with include keeping primary care physicians informed about the availability of new generic drugs which could help to lower health costs, the need for surveillance and alert of vaccine-preventable diseases, and finally, the need to help primary care physicians act quickly on drug recalls consumed by their patients. Please click on the link shown to read more about the significance of each of these problems. What makes our application unique is its interface with a FHIR resource, which allows us to drill down to patient-specific data to provide only relevant information without overwhelming the user, and its modern UI that provides a seamless, high-quality user experience. The development stack we chose helped us to provide a user interface that is expected and intuitive for the end user. This included Angular JavaScript, an open-source web application framework, and Firebase, a NoSQL real-time cloud database. The final result is both user-friendly and appealing and should be fairly easy to master for even the most casual internet users. Now let's take a look at a working demonstration of our application. First, we'll navigate to the application website and observe the 3 main areas of the patient search page. The menu at the top of the page, which consists of a title, search link, and alerts link. Patient demographics area in the middle of the page. And the FHIR population health alerts at the bottom of the page, which are currently emulated. The 4 alerts are CDC alert, new generic drug availability, new vaccine, FDA drug recall. Now let's click on the search link on the menu at the top of the page. The search page contains a data grid filled with patients from the FHIR server. There are 2 main areas of this page. The menu at the top, which consists of a title, search link, and alerts link, and the patient search results, which consists of a search box located at the middle top right to enter patient names. As the patient name is being entered, the results area below the search box will refine the list of patients to choose from. The patient results area is pre-populated with a list of approximately 1,000 patients. The data for these patients is divided into columns: patient name, patient ID, date of birth, gender, last alert type, insurance carrier, health provider, and FHIR URL. As you mouse over each row, you will notice a gray selection mode. Also, towards the bottom of this screen, you will see the ability to set the number of records viewable on the page, as well as the ability to cycle through potential patients in order to search using that method. Once you have found a patient whose status and data you want to review, hover over that patient's row. When the row turns a slight gray, left-click 1 time and you will be brought to the patient demographics page. Looking at the patient data page, you will notice the information for the patient selected is now populated with patient number, last name, middle name, first name, chart number, address, date of birth, date of last update, gender, marital status, home phone number, work phone number, and email address. On the left middle of this page, the work profile information was left for future development. This view now allows a healthcare professional to view patient data and alerts. All the patient data is being pulled live from the Fire server when the page is opened. It also has each health alert listed and will indicate which alerts are turned on and turned off in real time. At the bottom of the patient page, we have included a status indicator to show the communication link is active between our application and the Fire resource. The data visualization page shows alerts and patients in the format of a dendrogram. As you can see, we have 4 types of health alerts. These alerts are CDC alerts, FDA drug recalls, new generic drug availability, and new vaccine availability. Displayed here is a visual of user's mobile device with the EMRA emulator loaded. A user can turn off or turn on an alert by tapping on the name of the alert on their mobile device. Once an alert is turned off, the leaf node on the dendrogram associated with that alert will disappear and can reappear when the user has turned the alert back on. Users can also hover over each patient name, which will then show the patient data. Now let's take a minute to look at how our EMRA application interfaces with the Michigan Health Information Network Fire server. RESTful HTTP requests are made to the Michigan Health Information Network Fire server to query patient information. For the search and alert pages, results are cached from the Fire server to improve response times and UI functionality. On the patient information page, we pull the data live from the Fire resource when the page is opened. Also worth noting, since this is a proof of concept, we have no login page for authentication and authorization, and all information from the Fire server has been de-identified. The final part of our application is the alert notification emulator. There is one main section of the page with 4 predefined alerts: CDC alert, new generic drug availability, new vaccine, and FDA drug recall. These alerts can be toggled on or off by left-clicking on each one. When on, the title appears in color. When toggled off, the title appears in white. The alerts are also shown in real time on the patient and alerts pages of the EMRA application. We hope you enjoyed the working demonstration of our application. The final result can be found here along with each member of Team Eastbound and their roles. Thank you for taking the time to view our presentation.